What do you have in common with a waterfall, a bee and a flower, a little boy, and our aardvark? You're probably thinking that this is a trick question. Hard to imagine that a person has anything in common with all of these objects. From a scientific point of view, you have at least one characteristic in common with these things. They're all made of matter. Matter is anything that has mass and takes up space. It's that simple. Everything in the universe that you can see is made up of some type of matter. So the rule is if it takes up space, it's made of matter. Now light is not going to take up space, so that would be non-matter. Light, UV rays, X-rays, that kind of stuff is made of non-matter. All these things are energy, and energy is not matter because it does not have mass or take up space. For this video, we're going to investigate the properties of matter, so mass and volume and inertia, the things that define matter. So you're going to label your notes 1.1, the properties of matter. So the properties of matter, mass, volume, inertia. Let's talk about volume. What does it mean to take up space? So the word is volume when you're talking about taking up space. Your fingernails, the Statue of Liberty, continent of Africa, and a cloud all have volume. And because these things have volume, they cannot share the same space at the same time. So my phrase of the year that I want you to kind of ingrain in your head is that no two things can occupy the same space at the same time. So if I'm walking through a hallway, if you can imagine the air as being little tiny specks of particles, while I'm walking through that air, my body will push that air out of the way and form like this silhouette of my body. So my body will take the space of the air gets pushed out of the way, and the air will come in behind me and take the space that my body used to take up. Because no two things can occupy the same space at the same time, I need to move that air out of the way so that my body could take the place. So let's dive right into that word volume a little bit deeper. Volume is going to be a quantitative measure of how much space an object occupies. So you're probably wondering, well, what exactly does quantitative measurement mean? Quantitative analysis is going to measure data. It's more mathematical as opposed to qualitative analysis, which is going to be based more on observations. Objects are going to be placed in three general categories when you're talking about measuring volume. The first is going to be liquids, and your example would be water. And the instrument that we generally use when measuring the volume of liquids is a graduated cylinder. And you should know what a graduated cylinder is by now because of our quiz on laboratory equipment. And the standard unit of measurement for the volume of a liquid is a liter. Now in our lab, we're generally going to be using milliliters because we're dealing with smaller volumes of liquids. To measure the volume of a liquid, you want to get your eyes right at the level where that liquid is. And that line that you're looking at is actually called the meniscus line. MENISCUS. You want to write that in your notes. And the meniscus line kind of looks like a smiley face. You want to look at the bottom of that smiley face to measure the volume of that liquid. Now let's take a look at our own example. Let's say it's about 50 milliliters where our meniscus line lines up. We're going to say milliliters because it is a small unit, but you see that the standard unit for measuring liquids is a liter. So we will investigate how to convert liters to milliliters in a separate section. Another category to measure volume would be regular solids. An example would be a brick or your iPhone or a table, something that is regularly shaped, something that we can measure with a ruler, metric ruler, a meter stick. Your standard unit is going to be a cubic meter, and cubic meaning 3 because you're measuring 3 dimensions, length, width, and height. And in our lab, we're going to be dealing with centimeters. So you're going to get centimeters cubed as your unit. But you notice our standard unit is cubic meters. So if we get cubic centimeters for our answer, we just have to convert it if we needed to keep it in standard form. The last category of measurement for volume would be trying to measure a irregularly shaped object. So we're talking marbles, we're talking like a dinosaur or a watch, stuff that you can't measure length, width, and height. So you need to use a different technique in order to measure the volume of these items. And you're going to use something like a graduated cylinder in our lab. If it's something bigger, you would use maybe a bathtub or a pool, something that has measurement on it. But in our lab, we're going to be using a graduated cylinder. And the idea is that you're going to use the method of water displacement, where you would take an object like this rock and you would put it in the graduated cylinder. So if you notice right now, the volume of my graduated cylinder is 50 milliliters. And once I put it in, the water level will rise. And what you're going to do is you're going to subtract the final water level, or the meniscus line, and you're going to subtract it from the original meniscus line. So let's say I drop this rock in, it starts at 50 and it goes up to 70. So if I subtract 70 minus 50, I get 20 milliliters. So 20 milliliters will be the volume of that rock.
All right, so now let's discuss mass versus weight, because we said that matter is anything that has mass and takes up space. So taking up space means volume, which we just talked about. Let's talk a little bit about mass. So we're going to talk about mass versus weight especially. So mass is going to be the amount of matter in an object. How much stuff is packed into that space, basically, the matter in that space. So if you're looking at your computer right now, all the matter that's pushed into that little tiny computer that you have. Mass is always going to be consistent wherever you are in the universe. So if you look at your legs right now, and you slap your legs, you have matter in your legs and in your arms. Okay, if I take you to the moon, that's not going to change. You're still going to have the same amount of matter in your body right now if I took you to the moon. The only way that you're going to have less matter or less mass is if I cut off your arm. So if I cut off your arm, you're going to have less mass on the moon than you would on the Earth, but that won't happen. So you're always going to have consistent mass wherever you are in the universe. And I have, for example, you and a puppy. Basically, you made of matter, so you have mass. A puppy's made of matter, it has mass. But you have more matter in your body, or the space that you take up, than a puppy. So therefore, you have more mass. The unit for mass is grams. We're going to be using grams in our lab all the time. Now for you, I wouldn't measure your mass in grams. I would measure your mass in kilograms, because you're much more massive than grams. Grams would be like if I took your watch and I put it on a scale. I'd measure that in grams. Or if I took your iPhone and put it on a scale, that would be measured in grams. But you're too big, so you'd be in kilograms. Now let's talk about weight, because there's a difference with weight. Weight's going to be a measurement of the gravitational force exerted on an object. So that's a lot of words thrown in there. Basically, however much gravity there is, that's what's going to determine your weight. It depends a little bit on the mass too. The more mass an object has, the greater the gravitational force on the object. Meaning a more massive object like an elephant is going to have more gravitational pull, pulling it down. That's why I can't lift an elephant, because the earth is working really hard to keep that elephant down, versus a mouse. A mouse has small mass, therefore it has small gravitational pull. That's going to kind of relate to weight. An elephant's going to have a lot of weight because it has a lot of mass, and gravity is strong working on that elephant. But a mouse has less weight because it has less mass, less gravity working on it. It's kind of complicated, I know, but weight depends on gravity. So where am I going with this? If I took you, you have mass, and if I measured your weight right now, you have weight on Earth. But if I took you to the moon, what would happen? What would happen to your mass? Your mass would stay the same, because that's the matter in your body, but your weight would be different. Would it be greater or smaller? It would actually be smaller, because the moon is a smaller object and has less gravitational pull. So you're going to weigh less on the moon than you would on Earth. What about Jupiter? You're going to weigh more on Jupiter because Jupiter is a bigger planet. But is your mass the same on Jupiter? Yes. The standard unit of weight is called a Newton. And that's a little weird, I know, but we're going to practice measuring weight in class and using what's called spring scales. And spring scales are special devices to measure weight.
Here's a quick practice to convert from mass to weight. If you have a student that has a mass of 45,000 grams, which would be equivalent to about 45 kilograms if you convert it, how much does the student weigh in newtons? Well, it's really easy to figure out. First, you want to write out what you're given. So 45,000 grams was the number that you were given. Then you want to write out that conversion factor that I gave you. 1 newton equals 100 grams. You go ahead and plug it in, canceling out the grams, write the equation, 45,000 grams times 1 over 100 grams, and you do this so your grams can cancel out, one in the bottom and one in the top. So that's how you arrange it. 45,000 divided by 100 gives you 450 newtons. So this student will weigh 450 newtons. One last property of matter that I want to cover in this video is the property of inertia. Inertia is going to be the resistance to change motion. For example, if you have a ball in motion, you throw a ball down, you're playing baseball, that ball will stay in motion until an unbalanced force like the bat will cause it to stop moving or change its direction. So the inertia is the resistance to change. You are sitting in your chair right now watching this video. You do not want to change your motion. Therefore, you have enough inertia to keep you where you are, that the wind is not blowing you over. Inertia is directly related to mass. So the larger the mass, the larger the inertia. If you look at my pictures right here, if you play soccer with a soccer ball versus a bowling ball, it's all about inertia, why a soccer ball is designed the way it is designed. If you had a bowling ball, you have a bigger mass object and you have more inertia, which means more resistance to change in motion. You're going to need to exert a really large force to get it to move. Therefore, you use an air-filled ball because it has a low mass and low inertia, so you can change its motion pretty easily.